Emirates International was contracted to move a reactor pressure vessel, or RPV cask, from the San Onofre Nuclear Generating Station, known as SONGS, to Clive, Utah. The RPV cask measured 47 feet 7 inches long by 15 feet 5 inches wide by 19 feet 3 inches tall and weighed 1,470,000 pounds. Given the number of through truss bridges along the route, it was not possible to get all the way to the final destination on rail. Therefore, the goal was to find a rail route that would achieve an endpoint as close to the destination as possible in order to augment an over-the-road completion to the delivery site. Because of the large size of the RPV cask and the high number of narrow truss bridges along the route, identifying and confirming a suitable rail car was paramount to the success of the starting route identification process. After researching various rail cars for capacity, lifting, and shifting capabilities and location, it was determined that the KRL 3600, one of the largest Schnabel cars in the world, would accommodate the rail transport of the RPV cask. Based on the transportation configuration, utilizing the KRL 3600 Schnabel car, Emirates International started on a rail route survey to get as close to the Utah decommissioning site as possible. To perform the route survey, a high rail truck was used to run on the railroad tracks. Specialty lasers were mounted on the truck and calibrated to measure the widest and tallest points of the rail transport configuration along the route. The route traveled northward from the San Onofre Nuclear Power Plant and merged onto the Metrolink commuter rail line. At Santa Ana, the route transitioned to the northeast, past Victorville, California, and into Nevada. To accommodate the route to North Las Vegas, a new rail siding was constructed at the destination point that would give Emirates International access to offload the RPV cask. During the route survey with the high rail truck, over 40,000 data points were taken to validate the clearance along the route. It was determined that clearance was achievable from the SONGS facility to North Las Vegas. However, some of the through truss bridges before the North Las Vegas site were so narrow, measures were taken to minimize the width of the RPV cask to provide the best clearance window possible. The reduction in cask width was definitely needed to negotiate the through truss bridges at the El Cajon Pass. At one point, there was less than an inch between the bridge trusses and the RPV cask. While the route was being validated, the railroad owners were concerned about the potential for a catastrophic event. Since the gross weight of the KRL 3600 Schnabel car and the RPV cask weighed 2,220,000 pounds and the RPV cask was characterized as a low-level radiation, the railroad required a $100 million insurance bond. The bond would be used to mitigate damages if an accident occurred that may have shut down a rail bridge or closed the main rail line. The KRL Schnabel car had not been utilized for several years. Emirates International has owned and operated the BBC X1000 Schnabel car for over 20 years and has its own rail division. Unfortunately, the previous owner of the KRL 3600 and their operators were unable to train any of Emirates International's personnel. As a result, Emirates hired a consultant and, in conjunction with our railroad division, created a training manual. The manual was used to train Emirates crews before the unladen rail car traveled from the East Coast to the West Coast. Before the RPV cask transit to North Las Vegas, Emirates International provided the necessary training for each of the 5-man crews. In order to prep the KRL 3600 Schnabel car, Emirates International sent its rail crew to the site and performed a full inspection of the car and did an inventory of the spare parts. Because the car had remained idle for so long, a significant amount of maintenance and repair work was required. The most challenging repair was installing new main ball joints. A crane was needed to lift the upper section of the rail car in order to extract the old ball joints, replace the graphite housing, and then reinstall the new ball joints. In addition, the majority of hydraulic hoses, hydraulic hand pumps, and hydraulic brake system had to be either repaired or replaced. Once the necessary repairs were made on the rail car, it was then railed to the Songs facility. The KRL 3600 was large enough that even an unladen shipment required a designated rail classification or special train requirement. The cross-country trip included both Schnabel car halves, caboose, and 2 flat cars needed to carry spare parts and inventory items for the upcoming journey. The on-site rail spur would not accommodate the weight of the laden KRL 3600. Therefore, the track was removed and a new spur was installed. In addition, the RPV cask was outfitted with engineered steel supports which attached to each end. An H-section steel framework was installed on each end of the Schnabel car and would serve as a connection point with the steel supports of the RPV cask. The steel framework was secured by using an engineered torquing procedure to ensure its rigidity throughout the rail transport. The RPV cask was placed on 2 36-inch steel beams and a 13-inch hole was bored into each end of the beams. The 13-inch holes would then accommodate the 12.5-inch Schnabel car pins and serve as contact points for the self-supporting load. All of the loading and unloading procedures were implemented under a detailed work plan with hold points for customer sign-off. Any deviations from the rail work plan required new drawings, methodology statement revisions, and approval with sign-off by the customer. Emirates International was able to stay in front of the changes and preclude any work stoppages. In addition, Emirates International leased a trackmobile rail car mover to accommodate any movement of the Schnabel car when it was not hooked to a locomotive. The first leg of the rail route consisted of utilizing the Metrolink commuter line that runs between San Diego and Los Angeles. The maximum speed would be 15 miles per hour during straight transit. During lifting and shifting operations, the rail car could only travel at a maximum speed of 4 miles per hour. The KRL 3600 car was initially designated to run at 12-inch elevation above rail, which required the car to be lifted and shifted over 600 times. Emirates International engineers worked with the Railroad Clearance Department and determined the Schnabel car could travel at 6-inch elevation. This reduced the number of lifts and shifts significantly. The 36-axle Schnabel car started its journey at midnight in order to minimize the impact of the public transportation system. The goal was to run the train around the clock without stopping to get out of the high traffic areas and into Eastern California. Since a 24-hour operation was required, a caboose with sleeping quarters was used so that 2 crews could operate the rail car without stopping. The Schnabel car cleared the majority of the Metrolink stations by early morning. Surprisingly, there were a number of railroad enthusiasts that lined the commuter platforms during the early morning hours to witness the passing of one of the largest Schnabel cars in the world. The early morning crowd was not disappointed as they witnessed clearances on the platform and canopies that in some cases were within inches of the Schnabel car. As the RPV approached San Juan Capistrano, the San Juan Creek Railroad Bridge along the route was deemed as not structurally sound for the RPV crossing. As a result, shoring had to be installed under the bridge in order to support each of the 3 spans. The bridge deflection was monitored during the KRL 3600 crossing with a laser measuring system. As the train approached the bridge, it was stopped and then directed across the bridge by the local train master. The successful shoring effort kept the bridge deflection down to less than 1/4 of an inch for the Schnabel car's 2,220,000 pound gross payload. As the RPV cast continued along the route, the Emirates International crew had to perform over 300 Schnabel car lifts and shifts in order to avoid impediments along the way. Temperatures soared to 106 degrees as the rail car progressed through the Mojave Desert. At this point, it was required for the Union Pacific locomotive crew to change out to continue the rail car operation. Therefore, the Emmert Schnabel crew was able to disembark from the KRL 3600 and stay in a hotel at night. Emmert sent along 2 vans that would serve as chase vehicles in order to transport personnel and luggage from the KRL 3600 parking spot to the nearest motel. In some cases, the motel was more than 75 miles away from where the RPV cask was parked. Upon transitioning across the Nevada border, the crew was able to reach the newly constructed rail siding in North Las Vegas within 1 day. At the rail siding, the Schnabel car was spotted on the track, and then the locomotives were disconnected. Emmert International had mobilized the trackmobile from the Songs facility to the new rail spur in North Las Vegas. After the RPV cask was disconnected from the Schnabel car pins, Emmert International then utilized the trackmobile to move the Schnabel car halves away from the RPV cask during offloading sequence. In sum, the RPV cask traveled 366 miles over the course of 4 days without injury or damage to the equipment, utilizing one of the largest rail cars in the world. Dimensions and weight. Gross dimensions and weight of rail car and RPV cask: 277 feet long by 15 feet 5 inches wide by 19 feet 7 inches high, 2,220,000 pounds. Characteristics: travel through Metrolink public rail platforms, desert heat to 106 degrees. Around-the-clock travel to mitigate impact to commuter rail traffic during the day and evening. Planning the job. Man-hours involved: 2,560 hours. Regulatory approvals: approval from Union Pacific, Burlington Northern, Nuclear Regulatory Commission, Environmental Protection Agency. All work tasks followed a detailed work plan. Any changes required new drawings, methodology statements, and approval from the customer. Physical elements: terrain, Metrolink commuter rail stations with minimal clearances, through truss bridges with only inches of clearance. Weather: 106 degrees within the Nevada desert. Shoring present facilities: San Juan Creek Bridge in San Juan Capistrano, California. Building new facilities. At the loadout site inside the Songs facility, the rail was upgraded to accommodate the weight of the laden KRL 3600. At the destination point in Nevada, a new rail spur was constructed to accommodate the RPV cask offloading operation, which optimized the start of the next phase of the over-the-road transport. Installed a secondary hydraulic brake system on the KRL 3600 that had been removed. Safety considerations: driver train operator supervision, third-party consultants and rail coordinators riding rails in front of the KRL 3600 during transport that use detailed route survey to identify each lift and shift point along the route, as well as clearance envelopes for all through truss bridges. COVID-19 protocol was implemented throughout the transport process. Masks were required to be worn by everyone associated with the move. 6-foot personnel distancing was enforced whenever possible. Equipment use: rail car outfitted with tipping and overload warning system, radio communication. Precautionary measures: detailed route survey that identified any potential impediments along the route. Emmert International owns a similar Schnabel car, however the crew members received specific training on the KRL 3600 before the unladen transit from the East Coast to the West Coast. In addition, the 10-man crew again received training before the departure to California. Travel with caboose that allowed one of the 2 crews to take turns sleeping during the 24-hour operation. Execution: number of man-hours involved: 1,250 hours. Ingenuity: build new rail spur at destination to make final routing feasible. Innovation: modified RPV cask to minimize width and improve clearances.